Consider independent events A, B, and C, each of which can occur with the same probability P. If the probability of A, B, and C is 25% greater than the probability of A and B, then P is equal to A minus root B over C, where A, B, and C are positive integers, B contains no perfect square factors greater than 1, and A and C are mutually prime. Okay, so interesting thing to note here, this is probably a quadratic equation, because it's A, it's minus, it could be like plus or minus or something. So if each of these occur with the same probability P, the probability of A, wait, I'm gonna make sure I get my notation right, because I think this means the probability that each of these occur, but let me check. Okay, I get it now. So if we have A, B, and C, let's say this is when all of them happen, or one of them happens, or two of them happens, or when any amount of these happen. So let's say we have 8 cases. A, B, C. Well, I'm just going to say this is A, this is B, this is C in this table. Then we have probability 1 that this fulfills probability 1. Oh, that's like a perfectly straight line. And this fulfills probability 2. This is 2, this is 1. So A, yes. B, yes. C, yes. A, yes. B, yes. C, no. A, yes. B, no. C, yes. A, no. B, yes. C, yes. A, yes. B, no. C, no. No, yes. No. No, no, yes. And no, no, no. So this one is where any single one of them can happen. So this is this, and then no. Whereas this one, either A or B. So this, no, no. So the probability for number 1 is equal to, well, it's just going to be 1 minus p to the 7, right? Wait, am I just lying? No. It's just the probability that 1 doesn't happen to the 3 times the probability that another one doesn't happen. Whereas probability 2 is equal to just 1 minus p squared. So this one is 25% greater than this one. So 5/4 1 minus p squared is equal to 1 minus p, or minus c cubed. So it's divided by 1 minus p. This gets divided out, this goes to 1. So 5/4 is equal to 1 minus p. So I must be doing something wrong. Because right now I'm getting p is equal to negative 1/4, which clearly is not the case. I think I did this wrong. Oh, this is 1 minus. This is 1 minus, I see. And then this one is it also 1 minus? Yeah. So this one, so we say 5/4 times 1 minus 1 minus p squared is equal to 1 minus p cubed. Now is equal to 1 minus. So then we get 5/4 minus 5/4 times 1 minus p squared is equal to 1 minus p cubed. Subtract 1 from both sides. This turns to 1/4. We should multiply everything by negative. So we have 5/4 1 minus p squared minus 1/4 is equal to 1 minus p cubed. See, now we can't divide by 1 minus p, and I think the only solution here is to, like what happens if I put 1/2 in? I get 1/2. Here I get 1/8. Here I get 1/2 squared is 1/4. This is 5/64 or 5/16 minus 4/6, so that's 1/16. So I mean that's kind of close actually. But I think I just have to expand these because I can't really eliminate. So this is going to be 5/4 times 1 minus 2p plus p squared minus 1/4 is equal to this times 1 minus p would be 1 minus 2p plus p squared minus p plus 2p squared minus p cubed. Okay. So we get, and then expanding this here, we would get 5/4, which minus 1/4 is 1. Oh, this is how we, because this also is 1. I see. I was concerned on how we're going to solve this cube. Then this we get minus 5/2 p plus 5/4 p squared is equal to, this is going to be 1 plus p plus p cubed minus, no, plus 3p squared minus p cubed. So as we see, these two cancel out, and then we can divide by p. This goes to 2. Let's add this to both sides, so we get p squared then we subtract p from both sides, so we get minus 7 halves p. Oh no, that's our there's no p in there's no p in that. Let's first do this one. So we get 5/4 p minus 3p. 3p is 12/4. So 5 minus 12 is 7. So minus 7/4 p. And then we subtract 1. So minus 7 halves is equal to 0. Is it just quadratic equation time? I mean, I don't really want to. I'm just going to multiply by 4 because I don't want to deal with the fractions. 4p squared minus 7p minus 14 is equal to 0. So p is equal to 7 plus or minus the square root of 49 minus 4 times 4 times 14 all over 8. So we get 7 plus or minus the square root of 49 plus 16 times 14. 16 times 14 is going to be 256 minus 32 is going to be 224, right? Yeah, 224. 49 plus 224 is, I think it's 17 squared. We'd get 3. Oh wait, I was trying to multiply them. Shoot. Wait. 3, 1, 7, 2, 3. 273. What is 17 squared? It's not 273. Okay. Plus or minus 273. Oh yeah, we don't want this to simplify. Over 8. So is this a solution? We just add these together. We get 15 plus 273. We get 288. Let me check. That's 144 times 2, which is an interesting number. Actually, it was very, very close. This isn't correct, but I did... Okay, of course I did this part correct. And then I got... I don't know exactly where I messed up, but this is supposed to be 2. Which means that this would have to be 1/2. No. This would have to be... We multiply this by 4. Yeah, it would have to be 1/2. So how would this be 1/2? This would have to be 1/2. I don't know, they did it a different route than I did exactly, but they got to this part, but they had 2 here. And then that's how I got a different number here. This is supposed to be 32. But anyways, I think I did pretty well. I mean, I got these 2 things, which I didn't think I was going to be able to get, but I got these. So, yeah. Thank you guys for watching. Excuse me. Thank you guys for watching. I will see you guys tomorrow.